Sorry about that. So what I was saying about the absolute maximum was that it is the largest number in my range of y values that I have. So it is the largest number of my range for the graph. So obviously my range goes toward negative infinity, so that would be the lowest. So I have a relative minimum here at this point. Minimum. And what that means is that in that area, that is the lowest value. So the lowest value of y's in that area. However, as you can see, this is going toward negative infinity. This y value is going toward negative infinity. So it's just the relative. If I was to draw the other graph that's listed, it looks kind of like a W. Suppose like that. I have my lowest y value here, so this would be my absolute minimum. And this point here would be another relative minimum. So when I have an absolute max, this is the largest y value, or largest value in the range. And when I have an absolute minimum, it's the lowest y value. And relative is just like the local minimum or the local maximum. So here I have a localized maximum at this point. It looks like 0, 0. So that would be my relative maximum because the graph is increasing up toward positive infinity in the y direction. So that's the vocab for critical points and also extrema. We can do example 1 and maybe let's do example 2 as well. And because the graphs are so small on your notes, we can just kind of guesstimate the values. So if I'm looking at number 1 on your notes, looks like this. So I've got my origin, and I have a pretty skinny parabola. So it looks like that. And so what I'm looking for is any extrema for the graph or the function. And the graph is listed as f of x equals 2x squared minus 16x plus 27. So we could go through this and find the zeros and the y-intercept like we did in class today, but all I really want is the extrema. So all I really want is, does it have a relative maximum? Does it have a relative minimum? Does it have an absolute max? Does it have an absolute minimum? And so looking at a parabola, it's fairly straightforward because all it has is either an absolute maximum if it's going like that, or an absolute minimum if it's going like that. So we have the positive quadratic that we're dealing with here. So my absolute minimum would be located at this point here. And this is at point 4, negative 5, if you counted out the squares correctly on your graph. And I'd write that as absolute min. You guys can abbreviate if you want to. So then in number 2, I have the function of f of x equals minus x to the 4th plus 4x squared minus 2x minus 4. My graph looks really funky. So I have a pretty steep line going up, then it drops down, and it raises up again, and then it continues down. So I'm not going to have any absolute minimums on this graph because it's heading in the negative direction toward negative infinity for my range. However, I do have an absolute maximum, a relative maximum, and a relative minimum. So I'll start with my absolute max, which is at point, it looks like it's about negative 1.53-ish and 2.94-ish. So, or around 3. So I'd take negative 1.5 and 3 if that's what you guys looked at. Then I have a relative min at point, it looks like 0, 0 on the graph as well. So I would accept that. It does, if we were to solve this for the intercept, we would get a different answer. It would be a little bit further away from 0, but it's close enough where I'd accept that. And then I have a relative maximum here at point 1.27-ish and negative 2.7. So again, you guys can guesstimate those, and that's totally fine. But I hope that clears up the max, mins, extrema, and critical points. So to summarize, critical points. So critical points are where it changes shape, graph, changes shape or direction. And extrema are where they change direction. So this is extrema. And we can see those in absolute maximums, absolute minimums, relative maximums, and relative minimums. All right. So to cap off this unit, we started talking a little bit about behavior of graphs. So we were talking about, like, is the graph increasing? Is the graph decreasing? Is it staying constant? And so I'll flip this over. It's a little messy on that side, but when I'm increasing, I think you guys can probably guess what that means. But if I'm reading the graph left to right, it's asking me, is the graph increasing in a positive direction? Like, is it going positive, toward positive infinity? Constant is if there's no change, and I'll do an example of this from your notes in a minute. And then decreasing is it moving toward negative infinity? Or is it decreasing? Is the slope decreasing over an interval? So the graph that it gives us for the example kind of goes like this, then it goes like this, then it goes like this. It has these points here. And so from what I can see is that it is increasing from negative infinity, because I don't exactly know the point where it starts at, but I can guess, because there's an arrow here, that this is heading toward negative infinity in the x direction. So it's increasing, or the graph is going up, reading it left to right again, from negative infinity to about negative 1. And that would be how I'd write that. So it's increasing on an interval from negative infinity to negative 1. And I use this using, I write this based on domain values. It's constant from negative 1 to about a x value of 4. So I'd write that as negative 1 to 4. And then I'm decreasing, or my slope is going negative, from x values 4 to positive infinity. And so when I write the interval, again, the interval uses domain values to describe where it's changing from increasing to constant to decreasing. And I read it from left to right. So I'll do example 5 and 6. And if there are specific questions from this worksheet or the guided notes, please let me know. Reach out to me through email and we can go over these questions together. So on number 5, I have a graph that looks kind of like that. And I have arrows on both ends. So if I'm reading this left to right, I can automatically tell that the graph is decreasing here. There's a negative slope there. So I know that this is a decreasing section. And then I don't see any areas where it's flat or constant, where the y stays the same or the slope stays the same. But I do see this side here is increasing. So I can then write the interval based on where it's coming from in the x values. So from here it's coming from negative infinity. It's where it's like going on and on and on. And it ends at about about 3, where x equals 3. So this point, x equals 3 here. And y equals 1, 2, 5, I think, -5. So I'm not going to write that to confuse you guys. So it's decreasing between negative infinity to 3, and it's increasing then from 3 to positive infinity because there's no constant. In number 6, I have a reciprocal graph. So I have something that looks like this and something that looks like this. And then we have a point in the middle that they'll never touch. And I'm wanting to know where it's increasing. But if I look at the slope of both of these lines, so if I was to try and figure out what's going on, both of these lines are decreasing as I read left to right. So this one has a negative slope, this line has a negative slope, and then this one also has a negative slope if I'm reading left to right. So it is not increasing. And that's a perfectly appropriate answer. And it is decreasing, so it's decreasing from negative infinity to about 5. Or -5, sorry, from negative infinity to -5. And then it's decreasing again from -5 to positive infinity. So using interval notation, when I use this soft bracket or the parenthesis, I'm not including that number. So this is indicating that the x value will never equal -5. So the biggest part here, these were 2 simpler examples. The other ones, there's some funky graphs, like this one that looks like like that. So just identifying the areas where it's decreasing, where it's increasing, where it stays constant, decreasing, increasing, decreasing, increasing, and just kind of writing out the coordinate points. So finding the extrema points, and so then you know your domain values of what you're going to put for your interval. So that's all I got on those notes. I am going to continue doing this for symmetry, so I'm going to just jump right into that next. But again, take a look at your notes. You don't have to do any of the examples from the guided notes unless you want extra practice. So you don't need to do all of the guided notes. However, I do need you for your homework to do the odds for homework 2. So it's labeled homework 2, and I think the title is zeros, extrema, or intercepts, zeros, and extrema. And you're supposed to do the odds. So turn those into me ASAP if you haven't finished them already. I will throw on the online submission on Canvas. And email me with any questions. All right, good luck.